Okay, we are at 2.6. Identify the pairs of congruent angles in the figures. And explain how you know that they are congruent. Okay, so obviously the two 50-degree angles are congruent. So angle MSN is congruent to angle PSQ because they are equal. So angles are equal, so therefore they are congruent. Definition of congruent angles. All right, and then we have this 90-degree mark here, and we have a straight line. So that means that angle MSP is congruent to angle RSP, and the reason for that is that SP is a perpendicular ray to the line, and by definition of perpendicular, they're both 90 degrees, and all right angles are 90 degrees. And then you could do subtraction and learn that that's 40. If that's 90, then the other side's 90, and if that's 50, this is 40, and you could go and say that angle NSP is congruent to angle RSP. And there are the answers and giving their reasons of why they said what they said. Okay. Number 3, same thing. We have a straight line GJ. So let's go ahead and write this out. There's a straight line. And we have a 90-degree angle. So I know that that is a right angle. So the other side's a right angle. So we could say that angle GMK is congruent to angle JMK, because all right angles are congruent. And is there anything else we can see here? We have vertical angles there, so we could say those are congruent. So angle GML is congruent to angle HMJ, and that's because of vertical angles. You would actually write those reasons down, vertical angles. And I do not see any other vertical angles or linear pairs that match anything other than the other parts of your vertical angles. So these pieces, they're part of the vertical angles, so you would say those as well. So angle GMH and angle LMJ, and then that's again by vertical angles. Okay, and number 5 here. So what you're supposed to be looking at is these two lines on the scissors. Okay, so I'm going to get rid of all of that. That's what you're looking at. Really, it looks like this if you want to take it out and look at it. That's what you're looking for. So each one of these, 5, 6, 7, and 8, are individual problems. So because angle 1 is 143 degrees in number 5, that doesn't mean angle 1 is 143 degrees in number 6. So you're doing all new problems here. So number 5, angle 1 is 143 degrees. Okay, now you're supposed to figure out everything else. So the measure of angle 2 is equal to something, the measure of angle 3 is equal to something, and the measure of angle 4 is equal to something. Okay, so let's figure this out. If angle 1 is 143 degrees, angle 2 is a linear pair with it. So that means 180 minus 143 is 37 degrees. So that's 37 degrees. And then angle 3 is a vertical angle with angle 1. So that means angle 3 is 143 degrees. And then if you look at angle 4 and angle 2 are vertical angles. We already know angle 2 is 37, so angle 4 is 37. Okay, switch that around there. Okay, now we do number 7. So to do number 7, we actually get rid of all of this information. Okay, which those colors are still right. And we start over, angle 7. So number 7, measure of angle 2 is 34 degrees. So we need the measure of angle 1, we need the measure of angle 3, and we need the measure of angle 4. Okay, so the measure of angle 1 with the measure of angle 2, that's a linear pair. So if 2 is 34 degrees, then that means angle 1 is 146 degrees. All right, And then angle 3 and angle 1 are the same. So if 1 is 146, angle 3 is 146. And angle 4 is a vertical angle with angle 2. Angle 2 is 34. So angle 4 is 34. So that's how you do those. Let's go ahead and put the answer key in there. And there we go. It says the exact same thing as what we have there. Okay. Finding the value of each variable. These are vertical angles, so these two are the same. They're equal to each other. So write them equal to each other. 18y minus 18 is equal to 16y. All right? And it says find the value of each variable. So just find the value of y. We need to get them together, so I'm going to subtract 16y from both sides. And then I'm going to add 18 to both sides. Addition property of equality. And I'm going to divide by 2. Division property of equality. And there you go. Y is equal to 9. And number 11, same thing. Just set these up and work them out. Okay, so vertical angles. These two are equal. So 6y plus 8 is equal to 7y minus 12. And we can't solve that because, oh, we can. They're both y's. Sometimes they'll be different. You'll have to do the other two first and then substitute them in. So let's do these two. Set those up. That's going to be 4x equals 6x minus 26. So let's solve them all separately. All right, so subtract 8. And we're going to subtract 7y to the left. So negative y equals negative 20, or positive y equals 20. And on the right side, we'll subtract 6x and get negative 2x equals negative 26. Don't drop the subtraction sign. So divide off the negative 2, and x equals positive 13. Negative over negative is positive. Let's go back here. And there's your answers. Okay, to start this problem, we really need to just solve it. Don't look at what they did, just solve it. Set these two equal to each other and solve it, because you're supposed to correct these anyway. 19x plus 3 is equal to 13x plus 45. All right, so we're going to subtract 13x to the left, and we get 6x plus 3 equals 45, and we're going to subtract 3 from both sides, and you get 6x equals 42. And now we divide off the 6, and x equals 7. Same thing as if we do this side. 6x plus 2 is equal to 12x minus 40. Those are all vertical angles, so they're equal. So I'm going to subtract 6x from the left, and I will get 2 equals 6x minus 40. And now I will add 40 to both sides, and I get 42 equals 6x, and divide off the 6, I get 7. So both of them work the same way. Now let's see what they did wrong. They set 13x plus 45, and they added 19x plus 3 and set it equal to 180. Well, they aren't in a straight line, so they're not equal to 180. So that's what they did wrong. Make an argument. This says prove it. I wrote that in there. Your friend claims that angle 1 and angle 4 are congruent because they are vertical angles. Is your friend correct? And support your answer with definitions and theorems. Well, angle 1 and angle 4, angle 1 is not congruent to angle 4, and they are not vertical angles because those aren't straight lines. The other thing is, angle 1 is acute, and angle 4 is obtuse. We probably could keep going. Let's see what the book says. It says additional answers, and I'm not looking it up. That's good enough. Okay, so we have the givens here, and we're just going to fill them out, and then we'll do while we're filling that out, we'll go ahead and set up the two-column proof. So we have our givens, and that's angle 1 is congruent to angle 3. And then we say We have vertical angles here. Angle 1 and angle 3 are given to be the same. Mark it on your picture. And then we see vertical angles. 1 and 2 are congruent because of the vertical angles, and 3 and 4 are congruent because of vertical angles. So we can write that. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Those are all vertical angles. Okay? So look at what we have here. If the beginning is to the middle and the middle is to the end, we therefore can say angle 3 is congruent to angle 2. All right? So that's transitive property. It's not substitution. You're not substituting a piece here. You are doing a whole thing here. One whole side is being done. So that's really the difference. It's not a piece. It looks like substitution because you're just moving one thing into another. But this is transitive property. All right, so now you have angle 3 and angle 2 being congruent. And we know that angle 3 and angle 4 are vertical angles. So again, you have this line up. So beginning is to the middle and middle is to the end. So now you have angle 2 is congruent to angle 4, transitive property. And again, it looks like you're doing a piece, but you're looking at the whole side. That's what you're doing. So the difference between substitution and transitive property is you're not doing one little piece. There's only one on each side of that congruent side. So it is what it is. It's transitive property. All right. We can take a look at the book here. These are this is transitive property. That's transitive property. And there's your answer keys, just like what we have. And this proof here, we're going to start a two-column proof the same as what we did last time. So let's start our givens way up here. Angle 1 and angle 2 are complementary. And angle 1 and angle 3 are complementary. That's your given. So 1 and 3 are complementary, 1 and 2 are complementary, and 1 and 3 are complementary. So that must mean angle 2 and 3 are the same. So let's say this was 60, then that means if angle 1 and angle 2 are complementary, angle 2 has to be 30, because that's what complementary means. And if angle 1 and angle 3 are complementary, and angle 1 is 60, then angle 3 must be 30. Okay? So that's just using numbers to show you that 2 and 3 have to be the same. Now we have to prove it. Okay? So we're trying to prove that 2 and 3 are the same. So look at the paragraph proof they have here. They have the givens listed, and then by definition of blank angles, the measures are equal to 90. That means complementary, by definition of complementary angles. The measure of angle 1 plus the measure of angle 2 is 90. So let's write that down. The measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Definition of complementary angles. Okay? And blank is equal to 90 degrees. Okay? That would be the measure of angle 1. Measure 1 plus the measure of angle 2, 3, is equal to 90 degrees. Again, that's the definition of complementary angles. That's what complementary means. So where are we getting that? We're getting it from this given part. If they're complementary, that means their measurements equal 90. Definition of complementary angles. Okay, so now it says by the blank, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3. So because 90 degrees, those two expressions equal the same number, then we can rewrite those as the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3. Okay? And we didn't substitute. We're just saying beginning is to middle and middle is to the end, so that's transitive property. So this was complementary. Oops, that was the measure of angle 1 plus the measure of angle 3. And then by the transitive property, those two are equal. By the subtraction property, what are we subtracting? Subtracting the measure of angle 1. And we end up with the measure of angle 2 is equal to the measure of angle 3. Okay, whoops. by the subtraction property of equality, measure of angle 2 is equal to the measure of angle 3. So angle 2 is congruent to angle 3, subtraction here. Angle 2 is congruent to angle 3, definition of congruent angles. If they're equal, then they're congruent. If they're congruent, they're equal. All right, so there are your answers. Hopefully that helped.